Next in series is a freeloaded and afterloaded condition of contraction. This difference between the freeload and afterload is in continuation with isometric contraction and isotonic contraction. Next slide. As we know, non-contractile constituent or the muscle resides in series or it may be in parallel. So muscle tendon elasticity is a capability of the musculoskeletal system to get back to its innovative state or resting state. Or you may say they produce a resistance to contraction of the contractile unit. So the muscle contraction may occur when there is shortening of the muscle or no shortening of the muscle, or there may be involvement of lengthening. So there the non-contractile component or elastic component are of two types: parallel elastic component and series elastic component. As we know already, this is the isotonic contraction and this is isometric contraction. Both ends are fixed and the force transducer is attached to the one end of the. So the length tension relationship, passive tension curve measures when the tension exerted by this skeletal muscle at each length when it is not stimulated, or you can say at a resting stage when the load is already applied to the muscle. So the passive tension curve measures the tension exerted by skeletal muscle at each length. Total tension curve represents tension develops when the muscle contracts isometrically with maximal stimulus. And the active tension is the difference between the two, means total minus passive tension. Now the question arises, why the tension may be total tension, active tension, passive tension varies with the length. The tension develops is proportionate to the number of the cross bridges between the actin and myosin molecule. Maximum the cross bridges overlapping, the more tension will be developed. So the development of the active tension is proportional or proportionate to the cross bridges which are formed. So it is proportionate to the number of cross bridges which are formed. Now with this diagram it would be clear that the length of the sarcomere in micrometer, this is the length 2, 2.5, 2.4 up to this point. And if you find out the tension at this range is the maximum. And this is the point B and C. Here in the B you will find the maximum cross bridges formed. At this length again there is a maximum overlapping. So the maximum overlapping occur at this point. Okay? Once it is shortened, very much shortened, again there is overlapping. It's not proper. The cross bridges are not formed. And when it is too much stretched, then again cross bridges are not formed too much. There is a gap here. There is a coiling over here, actin filament, and proper distance between the actin and myosin is here. Same here, but not as much here. So the B is the optimal length of the sarcomere, which produces maximum tension. So it is also related with the length of the sarcomere, which is the unit of contraction. So the velocity of the muscle contraction, but the velocity of muscle contraction is inversely related with the load. It is not directly related, it is inversely related. Now, clear by the diagram. If the load is 0, velocity would be the maximum. Velocity of the contraction will be maximum. But if the load is increasing, velocity of contraction decreases. And one time will come with this load, there is no velocity of contraction. So the velocity of contraction is always inversely proportionate to the load. So maximal overlapping, there would be maximum active tension and maximum, not maximal, but this is a total tension and passive tension. If we minus the passive tension from the total tension, then maximal active tension can be estimated by maximal cross bridges overlap or optimal length of the sarcomere. So it is clear by this diagram. In the isometric contraction, both ends are fixed. During the contraction, again when the muscle contract in this side, you will find length remains the same, but tension of force increases. It is increases. No lifting of the weight. There is no lifting of weight. So if we fix the weight here, whether the tension is more or less, there is no work done. Very minimal work done. But in isotonic contraction, you will find one end is fixed, and during contraction, what will happen? There is contraction of contractile unit. Length is shortened. Once length is shortened, the weight which is hang to one end tendon of the muscle will be lifted upward. So the work is done with isotonic contraction. The workout W work out L multiplied by D, where the W is the work output, L is the load or force, D is the distance. And when the muscle contracts against a load, work is done, and why the energy is consumed here or why the work is done, that the chemical energy which is stored in tendon in the series elastic component is converted into mechanical energy and the external load is lifted. You will find the diameter, length, strength and the viscous supply is changed. But in hyperplasia, minimal hypertrophies occurs, but you will find splitting of the previously enlarged fibers, which occur when there is a rare condition, extreme muscle force generated. Once extreme muscle force generated. So once you lift the weight, you have to be cautious and must do under observation. So the hyperplasia of the muscle fiber may be done, or mainly the fiber hypertrophy may occur. Similarly, fiber atrophy may occur. Subscribe for further in physiology. Thanking you.